my name is Alexandru, and I will talk to you about predicting the interest in news based on image annotations. I see that we don't have that much time, so I will try to hurry a bit. So, as we saw in the first slide of Benjamin, the photos are displayed pretty big on the site, and we assume that they play a big role in the decision process when viewing a news site and deciding if you want to read something or not. Our goal was to understand what distinguishes good from a bad photo, and thus we compared the photos of 200 good articles with photos of 200 bad articles in each domain, and checked the labels that were assigned to the baseline label configuration that Andreas mentioned earlier. And we saw that there is a quite a mismatch between what we think makes the images important and what the labeler thinks is important. So we have researched alternatives for the labeling, and saw that the common architecture for image analysis is concurrent neural networks, usually used from 2012. They became common through the AlexNet concurrent neural network, which won the ImageNet challenge. So ImageNet is a database of 20,000 annotated image categories. So they have words or nouns assigned to images, and you can train a neural network to basically learn a model which can be used to predict labels on unseen images. The most common, or one of the most common frameworks used now is TensorFlow. It's open source and provides tools for machine learning and also deep learning and neural networks. And the models for that might be different, so you can train the neural network on different images and annotations, and we have seen that ImageNet is not very promising, so we reached out and did some research to see what other maybe sets of images are available, and compared open source and free solutions to commercial solutions, and assumed that for big players in the industry, there will be probably better quality. So we, in the end, decided to try out the Google Vision API. It uses TensorFlow for machine learning, but the images that are used to train the model are proprietary, so we do not have access and we do not know how many labels they have in total. But in general, the quality seems to be much better than the one on ImageNet. So when comparing the labels created or assigned to some of the images we had manually, the ones from Google Vision seem to be much more correct or precise. We also see that there's regular maintenance and updates because there are labels regarding relatively new topics, and they are also very expressive. So there is a long or a very descriptive label used usually. This means also that we cannot just use them to learn our prediction model for the news recommender. We have to do some pre-processing, and for now we just tokenize the whole string and use the first word, which is usually a noun, but not always guaranteed. And the big plus of using Google Vision is that they have an API that can be integrated really easily and most programming languages, and it's very robust. So from what we see is we have many labels with few pressions, and the pressions of labels depend also a lot on the domain. In general, we have 94,000 articles with each one having a photo, and calculating all the labels for the photos with probability 0.5 to 1, so means 50% to 100% sure that this label is assigned correctly. We have about 700,000 of labels, which are then again filtered to remove some of the really often occurring ones, resulting in 400,000 labels. We can also see that image labels are used differently than they are viewed. So the publishers might use a label more often than the readers want to click it. So And there are also domains that have less topics and stronger focus on one topic, so labels are occurring more often. After calculating all the labels, we have used the available impressions, so the view data that we have received from the contest organizers, to see the label popularity in each domain. So basically we have checked for each of the article how many impressions it has and used it to give these impressions to each of the labels. And as you can understand, some labels are used more often, so a normalization is required. And then the metric we used is average impressions per image label. And the sum of all labels of a photo would then be the predicted article views for the unseen news. We have then submitted the predictions calculated for the weeks that were not known, and we had to predict to the contest organizers, and we have seen really good results in the domain 13554, which is Mototo. In the other domains, the precision at 10 was not very good, but precision at 10% and average precision was better than the baseline. So our findings or conclusions are that the precision depends on the domain that we expect or that we look at, and some of the newspapers are dominated by few labels. The most common one on the motor talk were BMW, but also police and public transport seem to be labels that are often assigned to images that are liked by the users. So we also have seen that readers and editors or the publishers like different labels. So readers might click more often on one label than the editors publish it. Maybe this is an opportunity for the publishers to match their images to the ones that the readers like more, so to generate more views in general. And the other conclusion is that all the labels that we, or most of the labels that we get, are not really prepared to be used in recommender. So we have to pre-process them, and manual analysis is very important for that. So basically, having a look at the labels before using them and adjusting is very important and makes a big difference in the prediction quality. So for the future, we want to create a category of labels and analyze the domains that were not performing very well to improve them. We also want to get a bit more sophisticated when calculating the weight label and not just use the average impression. We want to also compare the popularity of labels for publishers and readers and see why there's such a big difference. And what will be also interesting is to analyze the co-occurrence of labels and words in the news snippets, which is currently a bit difficult because the snippets are usually German, but the labels are English. So we have to see how we handle this. And after having done this, it would be interesting to see how we can apply this to other domains. Yes, that's basically it. Do you have questions?